Welcome to this explainer. Look, I want you to literally picture the scene right now. You're looking directly through my eyes, taking a seat at a modern dual-monitor examiner's desk. It's quiet, the coffee is hot, and right in front of us is an interactive digital screen where Cambridge exam scripts are loading into the portal, one right after another. Up in the top right corner of our view, there's a live counter. It boldly displays scripts marked today, alongside a mark verification meter that is currently sitting flat at 0%. I am your chief examiner today, and we are going to uncover exactly how scripts are marked for one of the toughest, most fiercely penalized topics in AS and A-level math. I'm going to pull back the curtain entirely. I'm showing you exactly what happens in that grading room, highlighting the precise, split-second moments an answer confidently climbs into a top-tier marking band or tragically plummets into a failing threshold. Let's get to work. Okay, so let's dive straight into this quote, which comes direct from the principal examiner reports. This single sentence highlights exactly why candidates are losing literally thousands of marks globally every single year. It explicitly states that logarithmic and exponential functions are one of the most misunderstood areas in mathematics. Now, you might be wondering, why is that? It's actually pretty simple. Because when students face a multi-stage exponential equation under the crush of strict time limits, absolute panic sets in. The theoretical architecture they built in the classroom, it goes right out the window. They completely forget that we, as examiners, aren't just hunting for a correct final number at the bottom of the page. We're looking for a highly specific, standardized sequence of logical processing. When you misunderstand this core directive, you aren't just losing a careless mark or two, you're actively hemorrhaging points across the entire paper. But don't worry, we are going to fix that exact problem right now. Think of this as our mark scheme rubric for today's session. We'll be hitting our core principles, moving into the method mark strategy, covering the top examiner warnings straight from the grading floor, and finishing up with a live marking audit. Section 1. Core Principles. I am going to treat you like a junior examiner in training today, so buckle up. We begin with the anatomy of a question to see exactly what my brain is processing during the first 15 seconds of a scan. And yes, I really mean 15 seconds. When I pull up a high-tariff, multi-part Cambridge past paper question on this marking interface, my eyes are instantly darting across your page, actively searching your script for 3 distinct cognitive domains: knowledge, application, and analysis. This is where we desperately need to contrast Cambridge command words very, very closely. Look, if a question simply asks you to solve an exponential equation, well, that requires straightforward algebraic execution. But what if it asks you to evaluate or discuss the validity of a mathematical model using exponential functions? A C-tier student provides superficial breadth. They just frantically try to isolate the variable and call it a day. An A-star student, though, they provide analytical depth. They make explicit structural choices that clearly signal they are operating at a much higher level, actively justifying their mathematical steps and proving they truly understand the core assessment objectives. The theoretical architecture required for that coveted A-star relies heavily on precise definitions, causal relationships, and cross-topic connections. Let me be totally candid with you here. As an examiner, I get slightly weary reading script after script that just drops floating numbers onto the page with zero context. But when I see a candidate who clearly maps out the causal relationships between their logarithmic transformations, say they correctly justify the use of a natural log to bring down a variable exponent, and then they make an explicit integration or cross-topic connection with another syllabus area, like linking it to a differential equation boundary condition, boom. My mark verification meter instantly shoots to 100%. It's absolutely brilliant. This is the exact difference between a student who has merely memorized a formula and a student who actually understands mathematical architecture. Section 2. The method mark strategy. Now let's transition from theory to the physical act of grading with an apprentice-peer clash. We're going to demonstrate exactly how this strategy works in real time. The crucial takeaway here is that students are needlessly dropping grades by hiding their working, when method marks are literally designed to save your score. Okay, imagine I'm pulling up a split-screen viewport right here on our examiner desk. On the screen, we have a live recording of 2 students actively debating how to write a model response to a complex logarithmic equation. Let's call them student alpha, Alex, and student beta, Sam. Now, Alex is a candidate who aggressively dumps massive, unorganized paragraphs of algebraic facts onto the page, hoping something sticks. Sam, on the other hand, writes with beautiful, neat flair, but dances completely around the core mathematical command word. To absolutely guarantee those method marks, examiners look for a strict, 5-step standardized sequence when processing complex multi-stage analysis. Let's listen in on Alex and Sam's live debate. Alex slams a hand on the desk and says,
Listen, I'm just going to list the textbook definitions, extract the raw data, and jump right to the execution. The examiner is smart. They'll find the answer in the mess. Sam quickly shakes their head, looking stressed, and replies, "No way, Alex. Think about it. If we don't apply the relevant principles step by step, like explicitly showing the power rule in action, and verify the results with an evaluative thesis link, the examiner is going to penalize our script heavily for a lack of critical depth." They bounce these ideas back and forth under a visual countdown timer that's ticking away, editing their response live on the screen. As an examiner sitting behind the desk, you're practically yelling at the screen, rooting for them to realize they each hold half the puzzle. You absolutely must identify, apply, execute, verify, and present. If you skip even one, the method mark chain shatters.
Compare these two visual approaches on the screen to see exactly how explicit logical steps climb into those top-tier bands, while simply dumping an answer fails miserably. Alex's initial instinct is to just jump right to the final mathematical execution, writing down x equals 3.45. No working out, no causal relationships shown whatsoever. If that final answer is wrong by even a single decimal place due to a rushed, panicked calculator input, Alex scores a flat 0 for the entire page. It's brutal. Sam's ultimate realization, however, provides the perfect fusion: explicit algorithmic steps. On Sam's side, we see them taking the natural log of both sides, beautifully applying the power rule, and systematically isolating the variable, all perfectly formatted. Even if Sam's final line contains a silly arithmetic error, the examiner happily awards method marks for every single logical step above it. Showing your algorithmic steps is literally your ultimate exam insurance policy. Section 3, Top Examiner Warnings. I really want to pull back the curtain on the principal examiner reports right now to reveal the top 3 incredibly costly mistakes students make under pressure. Number 1, forgetting proper format. Number 2, failing to check presentation and terminology. And number 3, leaving answers that are not specific to the given context. Let's do a quick 30-second data scan challenge. If you were sitting in my chair and scanning a massive matrix of candidate errors, the single highest yielding trend of failure actually isn't bad math. It's bad presentation. It's missing clear headings. It's using completely incorrect terminology when defining a logarithmic base. It's solving for a decay constant k absolutely perfectly, but completely ignoring the physical context of the question. For instance, what if k represents a physical constraint like time? The student leaves a negative answer without explicitly writing a sentence explaining why that's mathematically derived but physically impossible in the real world. That is exactly where top marks vanish. Timeout. I'm physically pushing back from the examiner's desk for just a second. Before I grade this final model paragraph and show you the exact mistake that costs thousands of candidates their A-star, let's secure your own academic trajectory. Hit the subscribe button for Ace the Exams right now and turn on all notifications. Whether you are sitting for AS or A-levels, this is your absolute direct channel to outsmart the marking desk. Okay, rolling our chair back to the desk, let's look back at our students, Alex and Sam. Mid-argument, they hit a massive logical roadblock. They've correctly taken the natural log of both sides, but suddenly their mathematical evidence stops supporting their conclusion. As the examiner, I mentally step in, using a picture-in-picture view, and deploy the PEAL structure for them: point, evidence, evaluation, link. I watch in satisfaction as they rewrite their paragraph out loud, line by line, perfectly reconnecting that broken argument string. They deconstruct the prompt, extract the data, select the formula, execute the math, and present the findings. It is a truly beautiful thing to witness on a script. Section 4, Live Marking Odds. Let's actually hand the digital grading pen completely over to you for an interactive live marking audit. This is the Spot the Penalty Challenge. Imagine scanning a script right now where the final answer is just slightly off. We need to critically evaluate exactly where the weak link forfeited 5 critical marks. Take a close look at this authentic, albeit flawed, sample response in your mind's eye. The math starts out incredibly strong, right? The logarithmic identities are clearly recognized, the power rule is deployed correctly by elegantly dropping the exponent to the front of the equation, but suddenly there's a massive leap. A total jump in logic. They've evaluated an exponential decay model beautifully, but they haven't provided any evaluative thesis linking it back to the original physical constraint of the system. So I have to ask you, where exactly is the penalty applied? Grabbing our digital red marker, we can see exactly how failing to explicitly identify limitations or assumptions completely breaks the argument string. Looking at this table, in the execution stage, if the student's working was hidden, the red marker swiftly applies a loss of method marks. In the presentation stage, if the format was completely ignored, with no clear annotations to guide me, heavy deductions are applied.
And in the evaluation stage, if the context of the exponential model was entirely missed, the analytical depth simply fails. This, my friends, is the mark per minute velocity rule in action. As examiners, we are grading fast, very fast. If you hide your working or lazily skip vital steps, my red pen literally has no choice but to strike right through your potential method marks. You have to make it incredibly, painfully easy for me to award you points.
To securely lock in those top-tier marks, you absolutely must elevate your answer from a basic descriptive level to a highly evaluative one. When we talk about the final quality review pass at the desk, this quote is exactly what is ringing constantly in an examiner's head. Higher-order assessment objectives demand evaluation of alternatives, comparison of approaches, and justified recommendations. Look, it is simply not enough to just solve the exponential equation and walk away. You must actively evaluate the evidence quality. What are the strict limitations of this logarithmic model? What assumptions were mathematically made about the variables? Are there alternative interpretations that should be considered? When Alex and Sam finally assembled their completed, flawless response paragraph using these exact evaluative steps we just discussed, the final result was absolutely undeniable. Before you sit down in that hall for your AS or A levels, ensure you secure your academic trajectory by ruthlessly practicing these exact marking desk strategies on real past papers. I want you to visualize taking that flawless, evaluative paragraph from Alex and Sam, turning back to this digital grading portal on our desk, and confidently entering a perfect full mark score into the Cambridge system. Watch as the mark verification meter hits a glorious 100%. The script is officially cleared. That could easily be your script, provided you internalize the 3 universal marking truths we unpacked today: the 15-second structure scan, the mark per minute velocity rule, and the final quality review pass. Do not, under any circumstances, let your hard-earned knowledge go unrewarded simply because of poor presentation or hidden working. So I leave you with this to think about. How are you going to structure your very next math response? Are you holding back the critical analytical depth that we examiners are actively hunting for? Please do not leave those incredibly easy method marks on the table. Commit to this process, logically sequence every single step of your mathematical reasoning, and ensure your theoretical architecture is completely undeniable. Remember to subscribe to Ace the Exams, click the notification bell for our weekly examiner breakdowns, and right now I want you to leave a comment below stating your exact subject, your qualification level, and your current target grade. We will see you in the next Masterclass Explainer.